Good morning, girls. Children, we are doing chapter Quadrilaterals and we have completed exercise 8.1. And today I am going to explain you two more theorems. One is the midpoint theorem and one is a converse of the midpoint theorem. Okay. Now the midpoint theorem says that if in a triangle, okay, if in a triangle, uh, the midpoints of the two sides of the triangle, okay, if they are joined, it is parallel to the third side and is equal to half of that third side. Okay, so for that what we'll do first, we'll draw a triangle ABC in which we take the points D and E on AB and AC respectively. I hope children you are understanding what I am saying. We'll draw a triangle ABC and we'll take the points D and E on AB and on AC. We will join those 2 points and these 2 points are what? They are the midpoints. When we will join these two midpoints, we will get a line segment. Now this line segment DE, we have to prove that it is parallel to BC, which is the third side, and is equal to half of it. Okay, so I hope the statement is clear to you that the line segment joining the midpoints of the two sides of the triangle is parallel to the third side and is equal to half of it. So you will copy this statement and then we'll write the proof now. The diagram is triangle ABC in which D and E are the midpoints. Yeah. When D and E are the midpoints, now children you know that when these are midpoints, AD we will write given triangle ABC in which D and E are the midpoints. Okay, D and E are the midpoints. We write DAD is equal to BD and AE is equal to EC. Yes, so we write here AD is equal to BD and AE is equal to EC. Now we have one construction to prove. What we have to prove? We have to prove that this line segment DE is equal to half of BC, and we also have to prove that DE is parallel to BC. Construction is we will produce DE to a point F. So we produce this point, this line to a point F. This is E, and we construct it in such a way that DE is equal to EF. So produce DE to a point F such that DE is equal to EF. Yeah. Now you've got AD is equal to DB, A is equal to EC and D is equal to EF. Now, first proof. The first part of the proof, first I'll explain you children what we'll do in this proof. We will first these two triangles to be congruent. Okay. Why are we proving them to be congruent? Because when we'll prove them to be congruent, after that we'll prove that BCFD is a parallelogram. Okay, and then when this is a parallelogram, we can prove that these opposite sides are equal and parallel. Okay, so let's start with the proof. In triangle, see AED and CEF. Triangle AED and CEF, we know that AE is equal to CE, which is already given as E is the midpoint. And children, whenever we write any statement, we have to give the reason also. Then DE is equal to EF. This is by construction. And this angle AED is equal to angle CEF by what? They are vertically opposite angles which are always equal. So you have understood that one side A is equal to EC, then this DE is equal to EF. So we apply, therefore triangles are congruent by which conditions, which criteria? SAS condition. Now when the triangles are congruent, you know that the corresponding parts are always equal. So we will write AD, yes, we can see now, okay, can you see? AD is equal to CF. Okay, now AD is equal to CF, and one more we have this angle, angle ADE is equal to angle CFE, this angle CFE. Again, which reason? What reason? CPCT. So here also CPCT. Clear? So these two triangles are congruent, and these two angles and these two sides are equal by corresponding equal parts. Now we know that AD is equal to CF. We know that AD is equal to BD. Therefore by 1 and 2, what do we get? We get that BD is equal to CF. Now we got BD is equal to CF. Can we prove BD is parallel to CF? How will we prove that these two lines are parallel? You know that these two angles are equal and they are alternate interior angles. So here these two angles are what type of angles? We can write angle ADE, yes, is equal to angle CFE. Alternate interior angles are equal. Therefore AD, yes, is parallel to CF. Now we don't want AD parallel to CF, we want BD parallel to CF. So can we write D lies on AB. You can write these statements. D lies on AB, so therefore AB is parallel to CF. We can also say BD is parallel to CF. Okay, so after this you will write these two statements, and directly I am writing directly that BD is parallel to CF. Okay, what will you write after this? That since D lies on AB, AB is parallel to CF, therefore BD is parallel to CF. Now BD is parallel to CF, BD is equal to CF, therefore what? BDFC is a parallelogram. What is a special property of the parallelogram? That opposite sides are equal and parallel. So therefore, which two sides will be parallel now? Now DF, therefore you write DF is parallel to BC. Now E lies on DF, therefore DE is parallel to BC. This is first part proved. Okay, this is what we have to prove. Now it is saying that DE is half of BC. So what will we write for that? We will now write, we know that DF is equal to BC. Yes children, because opposite sides are equal in a parallelogram, you will write all these reasons. Now DF, you know that DF is equal to twice DE. Yes, because DE and EF are equal, so we can write DF is twice of DE. Now in place of DF, can I write BC? Yes, so this implies BC is twice of DE. Hence what? This implies that DE is equal to half of BC. So this is clear to you, I hope. That first these two triangles are congruent, then BDFC is a what? Is a parallelogram, and when this is a parallelogram, opposite sides are equal and parallel, so DF will be parallel to BC, DF will also be equal to BC, if DF is parallel to BC, since E lies on DF, DE is also parallel to BC. Then DF is twice of DE. In place of DF, we substitute BC, and therefore DE is now half of BC. So this completes your theorem. Which one? Midpoint theorem. And go through the proof. Write this complete proof in your notebook. And if you have any queries, you can ask me. Okay. I will now go to the next theorem, that is a converse of this midpoint theorem. Now in the converse, it is saying that the line segment which is joining the 2 points in a triangle, it is parallel to the third side, and out of those 2 points, actually only one is a midpoint, and we have to prove that the other point, that is E, is also the midpoint of AC. This was in my words. Now we will go to the proper statement. Converse. The converse is, the converse of the midpoint theorem is the line drawn through the midpoint of one side of the triangle, okay, parallel to another side, yeah, bisects the third side. This is the proper statement. So in simple words, I was trying to explain you that if in a triangle ABC, if D is a midpoint, yes, E is a point which is lying on AC. Now DE is parallel to BC. We have to prove that E is a midpoint. So the line drawn through the midpoint of one side of the triangle, parallel to another side, it bisects the third side. That is, we have to prove that E is a midpoint of AC. So you will write the statement and then draw the figure. Now for this, converse of the midpoint theorem. Converse of the midpoint theorem. Yeah. Let us draw a figure. Again ABC, and let this be a point D, which is a midpoint, and E is a point which is lying on AC. So we write given. What is given? Triangle ABC. D is a midpoint of AB, and DE is parallel to BC. Okay, now we have to prove that E is the midpoint of AC. Okay, can you see? I hope this is a dark. E is a midpoint. Now let us construct. Here also we have a construction. Let us take a point F. Okay, here. So take a point F on AC such that F is the midpoint of AC. Okay, take a point F such that F is a midpoint. If F is a midpoint, you know that AF will be equal to FC. Now starting with the proof. Now if D is a midpoint, we know F is also the midpoint. So we write, according to the midpoint theorem, DF, yes, DF will be parallel to BC, yes, and DF will be equal to half of BC. Okay, now compare this and this. If I say DF and DE, these two are intersecting lines. Can two intersecting lines be parallel to the same line? So you will say no, because this is against the parallel line axiom, that two intersecting lines cannot be parallel to the same line. So we write We also know that DE is parallel to BC. Now DF and DE, we write DF and DE, yes, are intersecting lines because they have a common point. Yeah, DF and DE are intersecting lines. So we will write this is 1, this is 2. So we write by 1 and 2, two intersecting lines cannot be parallel to the same line. Yes, so we will write, and what is the same line? BC. So we write two intersecting lines cannot be what we have assumed that DF is parallel to BC and DE is parallel to BC, this assumption is wrong because two intersecting lines showing that they are parallel to same line, which is against the parallel line axiom. Okay, so therefore we write after this that this contradicts our statement. Therefore our assumption is wrong. Yes, our assumption is wrong. Therefore E and F are the same points. Therefore E and F are the same points. They are not two different points. Therefore E is the midpoint of AC. Okay, did you understand that after this what you will write, that these two lines are parallel to the same given line, which contradicts our statement. Our assumption is wrong and therefore E and F are the same points. Hence D, E, or in the end we write that E is the midpoint of AC. Okay. Therefore this completes your proof, children, and now you will copy this proof, first one as well as the converse of this, that is a midpoint theorem, and tomorrow we are going to start with the exercise, next one, 8.2. okay, and I hope anything, if it is not clear, you can ask me. So today we have completed two theorems. Go through them, write this in your notebook, practice them 2-3 times, and these are easy, they will not be difficult for you to understand, and tomorrow we'll start with the next exercise. Thank you, children. Have a nice day.